Just minutes ago, the James Webb Space Telescope discovered the first-ever galaxy that challenges our understanding of the universe. This galaxy is so ancient that it shouldn't even exist yet, suggesting that we may have to rewrite the textbooks on the beginning of the universe. The implications of this discovery are monumental, throwing our entire understanding of space and time into chaos and forcing scientists to rethink everything. This discovery suggests that in this century, we might pick up signals from an extraterrestrial civilization, a prospect that excites and baffles researchers alike. This newly discovered galaxy, so old it defies our current understanding, is part of a universe that existed before our own creation. It's a godlike entity that forces us to question the fundamental laws of physics. About 1/5 of the galaxies observed by the James Webb Telescope have Earth-sized planets, indicating the potential for life elsewhere in the universe. As scientists scramble to make sense of the data, they are faced with the seemingly impossible: how can a galaxy be older than the universe itself? This discovery defies the cosmos and places long-held theories under scrutiny, prompting researchers around the world to unravel this cosmic puzzle. The crux of this scientific quandary lies with the unparalleled capabilities of the James Webb Space Telescope, which has peered further into space than ever before. Each celestial image captured by the telescope opens a Pandora's box of questions that could occupy scientists for decades. The discovery of this ancient galaxy could either deepen our understanding of the universe or reveal how much we don't yet know. While the future is uncertain, one thing is clear: the James Webb Telescope has forever changed how we see the universe. This remarkable find is making us rethink everything we know about the cosmos. If a galaxy older than the universe itself exists, it might mean that the universe is older than we thought, or our methods of measuring age might be wrong. Scientists are busy comparing their data with other tools to confirm or disprove what the James Webb Telescope saw. This search not only tests what we know but also highlights the ongoing effort to uncover the truth in science. Reviewing all this data takes time and caution, as scientists want to be certain before declaring such a significant shift in our understanding of the universe. As this process unfolds, the scientific community is abuzz with discussion and debate. Some are skeptical, thinking that it might be an error, while others are excited about the opportunity to learn something new and advance our knowledge of the universe. This discovery has sparked a lot of interest and will likely lead to many more studies and research projects. The James Webb Space Telescope is diligently studying the far reaches of space, gathering precious information from distant galaxies. Each finding adds to scientists' knowledge about the universe, providing insights into our origins and the cosmic forces at work. Recently, it identified an old galaxy, a significant event in the quest to understand more about the cosmos. As the telescope sends back more data, astronomers use it to test their theories and improve their models of the universe. They are also searching for other old galaxies and cosmic events that might explain the early universe's conditions. One particularly interesting discovery is galaxies so old they appear to have formed before the Big Bang, thought to have occurred about 13.8 billion years ago. This creates a puzzle for scientists, forcing them to reconsider the Big Bang theory. Following the release of the first deep field image from the Webb telescope by NASA, researchers have found new evidence that challenges what we know. Rohan Naidu, a young astronomer at Harvard, and his team discovered a galaxy called Glass Z13, which seems to have formed just 300 million years after the Big Bang. This discovery has sparked worldwide discussion, challenging our current ideas about galaxy formation and the timeline of the cosmos. The discovery of Glass Z13 suggests that we might be missing important information or that our understanding of cosmic history needs revising. The universe keeps revealing surprises that challenge what we know and push us to explore even deeper. Glass Z13 and other galaxies like it highlight significant gaps in our understanding of the universe's early moments. This ongoing discovery process is crucial, as it drives the scientific community to continually test and revise our theories, striving for a clearer understanding of our cosmos. The identification of galaxies like Glass Z13 and Mace's galaxy has significantly shaken our current understanding of how galaxies form and develop. These galaxies should be several billion years old according to established scientific models. However, startling research suggests they formed only about 270 to 300 million years after the Big Bang. This timing suggests they began to take shape before the universe itself had officially begun, according to our existing knowledge of the Big Bang. This situation presents a substantial challenge to astronomers and physicists alike. The existence of these galaxies, which exhibit characteristics of much younger galaxies while maintaining a level of structural complexity expected in older galaxies, raises serious questions about our fundamental theories of cosmic evolution. The issue became even more intriguing with the confirmation of Mace's galaxy, named by astronomer Stephen Finkelstein in honor of his daughter's birthday. The existence of another such galaxy reinforces the notion that these are not mere oddities but indicators of a significant gap in our understanding of cosmic history. The scientific procedures used to determine the age and characteristics of these galaxies have been thorough, with data cross-verified through multiple tests. This solid evidence makes it difficult for the scientific community to dismiss these findings as errors or anomalies. For now, astronomers are carefully examining all aspects of these findings, aware of their profound implications. Further investigations and more data are needed to fully understand how these galaxies fit into the broader cosmic picture. The ongoing study of Glass, Z13, and Mace's galaxy promises to potentially reshape our understanding of the cosmos, urging scientists to possibly rewrite parts of the cosmic rulebook. As the James Webb Space Telescope continues to explore the far reaches of space, it brings us closer to understanding the early universe. This journey of discovery, filled with both challenges and excitement, is essential for advancing scientific knowledge and expanding our understanding of the universe. The universe's mass consists of about 27% dark matter, which is invisible since it neither emits nor absorbs light. If dark stars exist, they would mark a significant departure from our understanding of star mechanics. Theoretically, dark stars could have formed around 300 million years after the Big Bang, during a very young period of the universe. Scientists have identified certain unusual radiation signatures that don't match those of any known stars, suggesting these might be from dark stars. However, this is not confirmed, and no one has ever directly observed a dark star. The idea of dark stars is an exciting development in astrophysics because it challenges the traditional view of how stars work. If proven, it could reshape our knowledge of the universe's early stages. These stars are interesting not just for their unique power source but also because they represent an entirely different model of stellar behavior. Dark stars introduce new possibilities, hinting at stellar giants powered by unknown forces. Despite the potential implications, dark stars remain unproven. The radiation that some scientists point to as proof could, in reality, be from other unknown sources. The concept of dark stars invites us to consider broader possibilities in the cosmos, but it also requires rigorous testing and validation. Researchers continue to study these signals, hoping to confirm whether they indeed indicate the presence of dark stars or if they have a less extraordinary explanation. The idea that dark matter manifests solely through its gravitational effects on visible objects might gain support with the notion of dark stars. Should these colossal stars be real, they would serve as indirect proof of dark matter's existence. Such a discovery could significantly deepen our understanding of dark matter, a component deemed vital to the foundation of the universe. By examining dark stars, scientists might unlock hidden secrets about the universe's structure. Dark stars differ from typical stars, emitting light up to 10,000 times brighter than their contemporaries and being significantly larger in size. Their role in the early universe could have been more substantial than previously anticipated. During the era when the universe re-illuminated after a prolonged darkness, these stars likely played a crucial role in the formation of galaxies, illuminating aspects of the universe that had remained elusive. This potential discovery suggests that dark stars could be viewed as the universe's initial luminaries, casting light after an extended dark period. Their influence on galaxy formation could provide answers to lingering questions about galaxies whose existence seemed inexplicable until observed with advanced telescopes like the James Webb Space Telescope. It seems that the contributions of scientists like Fritz Zwicky and Paul Dirac, whose work had been overshadowed over time, are gaining recognition once again. Zwicky, in particular, conducted seminal work on dark matter. Although their contributions were not widely discussed for years, they are now appreciated as potentially holding keys to understanding that puzzle. This resurgence of interest exemplifies a common theme in science: previously overlooked ideas can later become pivotal to significant discoveries, underscoring the importance of considering all ideas regardless of their age in the quest to decode the universe's complexities. Among the lesser-known concepts in astronomy is the tired light theory introduced by Zwicky. Renowned for his extensive research on galaxy clusters, particularly the Coma Galaxy cluster, Zwicky proposed the existence of what he termed dark matter due to gravitational effects that visible matter alone could not explain. Initially met with skepticism, this concept has since become integral to modern astronomy. Zwicky also put forward the tired light theory, which posits that light loses energy and thus appears redshifted as it travels through space. This theory, proposing that light's energy loss results from interactions with space particles rather than from the stretching of space itself, starkly contrasts with the prevailing theory attributing redshifts to the universe's expansion. Although this theory of tired light offers a straightforward and understandable explanation for redshifts, it hasn't won over the scientific community. It challenges the more exciting idea of a universe that is constantly expanding, suggesting instead that the universe might be more static and that light simply loses energy over long distances. This less flashy, though potentially enlightening, view hasn't captured as much attention or acceptance. This situation highlights the difficulty new ideas face in gaining recognition and acceptance in the scientific world, especially when they propose a simpler, less dramatic view of the universe. Zwicky's tired light theory serves as a case study in the challenges faced by theories that clash with established scientific beliefs. It reminds us that in the realm of science, being simple or straightforward does not always equate to being accepted or celebrated. Instead, the theory continues to be a topic of discussion and debate, underscoring the complex dynamics of scientific acceptance and the sometimes slow pace at which the field embraces new ideas. If the shifting of light to red in the universe really means it's just tired, then almost everything we thought we knew about how old the universe is and how old the galaxies identified by the James Webb Space Telescope are might be completely wrong. This would mean our entire understanding of space could be based on incorrect assumptions. The idea pushes us to rethink the entire basis of how we calculate and understand the cosmos, which we've been getting wrong for quite some time. Looking back at past theories, we find that the universe's rules might change over time, making us rethink everything. One of Paul Dirac's major contributions was the Dirac equation. This important formula helps explain how these tiny parts called particles behave and even predicted the existence of something called antimatter. This was once only a theory, but is now a key part of our understanding of the universe. However, Dirac didn't stop there. He boldly suggested that the so-called constants of nature, these are the basic rules that all of physics is built on, might not actually be fixed at all. Dirac thought these constants could change as the universe ages, which means that things thought to be permanent and unchanging might actually shift over time. This theory is quite shocking and challenges the very foundation of what physicists have believed for a long time. It suggests that our methods for understanding the universe might be outdated, similar to trying to use an old map to find your way in a city that has since changed. If Dirac's ideas are right, it could mean that the physics community is in for a big surprise, needing to re-evaluate the basic rules that were thought to be absolute. The impact here is significant. Our tools for studying space might not just be slightly off, but could be fundamentally flawed based on no longer correct assumptions. This could mean that much of what we understand about physics might need a major overhaul, showing that even with all our scientific advancements, our view of the universe might be less accurate than we thought, resting on shaky grounds that need to be updated and corrected. This poses a huge challenge for scientists, pushing them to update their understanding and possibly rethink many of the principles that were once seen as the unshakable truth of how the universe operates. There was an idea that the fundamental forces that hold the universe together might change over time. This theory, suggested by a scientist referred to as Dirac, was initially dismissed as too unconventional during his lifetime. It didn't fit with the mainstream views of astrophysics back then and was set aside as a mere curiosity not worthy of serious scientific exploration. As time has passed, however, this notion has come back into the spotlight. The standard principles of physics, which have long served as the foundation of our understanding of the cosmos, are now being questioned. New findings in the study of the universe are revealing more inconsistencies than ever before, suggesting that perhaps these forces are not as fixed as once thought. The idea that constants in nature might actually vary is gaining traction once again. This shift in thinking is helping to explain some confusing observations, like those concerning the cosmic microwave background radiation. This is essentially the leftover light from the early universe. The patterns in this radiation don't always align with what our old theories would predict. Similarly, the way distant galaxies appear and behave challenges our previous understanding of how the universe has grown over time. A Canadian scientist named Rendra Gupta has taken a fresh look at these old theories, integrating them with new data. Gupta has come forward with a radical new estimate that suggests our universe might be much older than previously thought, 26.7 billion years, according to his calculations. Another version of his calculations even suggests the universe could be as much as 40 billion years old. These new estimates dramatically depart from previous figures and suggest that the universe's very early stages might be beyond our capacity to directly observe. Did this video challenge your view of our scientific capabilities? Are we aiming too high with the God formula? Like, comment, and subscribe for more.